Okay, right. Now, great privilege this one, and real glamour in it, because this is aircraft of a remarkable new type. John McGuinness and his family are here. It's a family enterprise, and he's going to tell us about it, because we do know from our own research in our reports, we've got a report on drones and a report on manned aircraft. We know that these things, the time has come, and obviously the market for drones is multi-billion-dollar already, and the interesting thing is now passenger aircraft. They're coming right, the small aircraft, but we need to hear not from me but from the expert. John, can you fill us in and how you're moving it forward in a remarkable way?
I'd be happy to do so. This is a family project to create a technology demonstrator for a breakthrough in our understanding of why we never conquered a particular domain of flight very well. We fly very efficiently with commercial aircraft, and we can fly very slowly with gliders and sailplanes with efficiency. But an airplane that's 150 to 450 miles per hour, we use 6 to 8 times too much energy for the amount of momentum we achieve. So the breakthrough allows us to use active drag reduction and other drag reduction principles, create more stability and control. And for the world of electric vehicles, it's transformative. We have the ability to carry more weight without the weight penalty, without the architectural penalty of the batteries or so on that would store our energy. So in an electric implementation, this aircraft, we can fly a family of people for 3 hours, and we'll fly so fast that we have a tremendous range.
Right. Now that's initially with diesel, is it?
No,
you're going to later be electric, or
I was specifically referring to an electric version.
Excellent.
Yes.
Okay, right. But how are you starting? When will you have something for sale?
Well, the problem is that you can't have something for sale. You have to have lots of somethings for sale, because everyone really needs this as a fundamental need.
Yeah. So will you manufacture or license?
Our pathway gets us to an awareness among the public that's a little bit hard to meet. So we have to market first to our niche early adopters in the kit markets, and we have to develop certified versions, but we mostly have to have a real product, and our real product is the ability to manufacture these in scale, to deploy them at low cost and high volume.
So that means a partner?
Oh no, it means an entire industry and a reimagining of that.
Right. So it's nowhere near soon, or what?
It's a long process.
Right.
It's like eating an elephant one bite at a time.
Aha, right, okay. But this is no elephant. This is gorgeous. Now, I think you told me that you had working models. This is not.
That's one of them.
That
sure.
is working.
Yeah, that's a 33%
So
scale.
what we're seeing here is something that looks like nothing on Earth, basically. And I know that I insulted you by referring to a box wing, and you corrected me. So could you tell us about the aerodynamics? What's clever?
There are 6 ingredient technologies. First, we have a passive drag reduction suite of technologies, starting with our configurational advantage. The double box tail configuration gives us stability and control by means of induced drag reduction. Means I can carry more weight for a given span with less penalty. It leads to natural laminar flow and subsonic area ruling as technologies that help us break through this barrier. And once we reach the speeds where these technologies are most relevant, we also reach the domain of active drag reduction. When you get into the higher speed ranges, we can mitigate drag directly through the application of power. And we can use boundary layer control and wake propulsion as ways to take away most of the need for more thrust and more installed power.
So we're basically talking about improved aerodynamics giving us longer endurance, longer range. But what is the twinkle in your eye? Is this something that's a trainer aircraft, a tourist aircraft up for an hour when it's electric and working at any time of the day and night, of course, because it's pretty well silent? Or is it something that's going to be a feeder aircraft for 20 people? Or what's the sweet spot?
The sweet spot is every human needs on-demand regional mobility for a small group of people. Right. And we don't actually have that. We have an automobile, which gives us on-demand local mobility, and we have airliners, which give us on-demand intercontinental mobility. But in the smaller distances, say between 2-hour drive and all-day drive, there's nothing but pain. We use airliners the wrong way. So having an autonomous smart plane that doesn't require extensive pilot training, wherein a user can say to his electronic assistant, we'd like to fly from here to there, that's the holy grail. And what's missing is not the technology of that part. That's easy. We've had autonomous airplanes for 50 years. What's missing is that we never built real good aerodynamics into the small airplanes. We couldn't have, because we were taught something that isn't quite correct in our physics a long time ago.
But are you perhaps getting a bit ahead of yourself in that you say autonomous planes? The autopilot in an airliner is not true autonomy, and the airliners, I thought, don't do a very good job of collision avoidance, identifying flying objects from other planes or birds coming towards them. They're not really very good at that. So in terms of true autonomy, we had drones, but not planes with people in, do we?
Yes, we do.
We do.
We've actually had self-flying autonomous airplanes and that technology for more than 50 years.
Right.
And by comparison, you know, the hazards of driving down a narrow pathway with dogs running out in front of the car and other things, the threat matrix is overwhelming.
Yes.
Whereas in the sky, you can go out in the sky and, you know, if you're anywhere even supposedly near an airport, you'll look around and you'll see there's nothing but empty sky.
It's pretty empty, but nevertheless, if air traffic control made a mistake and you were heading straight towards another plane, it doesn't do a very clever job of telling you about it and dealing with it.
Modern systems can identify that and manage that better than humans can. And we have that technology already packaged today. Commercially available off-the-shelf technology can navigate, fly, and emergency land almost any aircraft.
Excellent.
And we need a home to take that simple technology and put it to use. The missing ingredient is the efficient aircraft.
Yes, right. So we're going to have autonomous cars, which almost certainly are not going to be private cars much. They're going to be autonomous taxis. And you sound to me as if you're talking, at least in part, about the flying version of that. Some of these will be air taxis, is that right? They won't necessarily be all privately owned.
The majority of Earth species fly for the simple reason that it's the most efficient way from going from one arbitrary location to another arbitrary location. This decentralizes everything. Instead of having a concentration where airliners are forced to land every minute on this tiny little strip, we take all those people and we distribute them out into where they really want to go, and they don't even come close to concentrating together. So the autonomy allows people to reduce their regulatory burden and their training burden. And the timeline of how this deploys is such that the infrastructure and the regulation precedes the availability of adequate numbers of vehicles.
Okay, and there's obviously a lot of development paths on all these things. Can that have a range extended significantly, like the Bi-Aviation and other planes with solar wings? Is that a useful adjunct at some stage? It's not central, but I mean, will that help?
We have a proprietary technology which is pretty competitive. We're not disclosing, but in which range is really not a principal limitation for us. So
without solar, just
solar can certainly play a part. And we're interested in that. Yes, absolutely.
Right.
We also feel that electric is the preferred method for propulsion integration. It's not necessarily an energy-dependent arrangement. It's energy-independent. So I can have hybrid systems in which I have fuel sources, for example, for the high-power climb-to-altitude applications. But we have a drag mitigation technology that allows us to put an object in motion and have it remain in motion because we're removing the only thing it's acting against, which is the viscous atmospheric drag of having lift and moving very quickly.
And in terms of, again, a twinkle in your eye, a technology roadmap, what about extremely short takeoff and landing? Are these going to be taking off from the terminal building literally on top of the terminal building by means of motors in the wheels before the propeller gets up to speed? Do you dream of those things too?
Yeah, you're talking to an aircraft designer. So of course we have vertical takeoff and landing aircraft that follow on. We have multiple iterations of other and related technologies. We even have the future flying car. It's not time to talk about any of those things. It's time to look at the history, the facts, that we didn't fix the problem in one aviation domain of making something that the public can operate.
Yes.
We want to do that first.
Yes. Oh, that's nice. And we're all going to be living in cities, or most of us, 70% soon, and 2080. Well, so they say. But I mean, that seems to be the trend.
Cities are an outgrowth of our lack of regional mobility.
Well,
the 20-minute commute or the half-hour commute, whatever our time budget is, that defines the area in which we live. And if we increase that time budget through affordable regional mobility, we decentralize our need for cities. We don't have to bring everything in the city to our home environment, and we don't have to worry about leaving our home environment for other resources nearby. Where I live in Montana, it's 5 hours to those resources, and it's over mountain passes in the winter. So aviation turns that 5 hours into a half hour.
Yes. In terms of where we are now, though, there are more than half of the people in the world living in cities, and in terms of easing that situation, what's the sort of minimum endurance needed for approval of any form of aircraft, vertical or this type, in a city? I mean, we see things like the volocopter and the Chinese unique, drone, manned drone. I mean, these things are sort of like 20 minutes, 40 minutes, not even an hour. That sounds to me something extremely dangerous in a city. Surely it will not be allowed to fly in a city if it has that level of margin of safety. There's no margin of safety, but one day they'll be better.
Yes,
but do you have a view on that? I mean,
the pace of the required change is slow enough that most of those issues evaporate before they cause trouble for us, because the number of vehicles and the deployment of the vehicles are up against regulatory barriers and science barriers, manufacturing barriers and other barriers. So we feel like one thing we can do that helps a lot is understanding that our desire is shared for safety and economy and range and all of these things, noise abatement, and it all revolves around the design of the vehicle itself. So if you have a powered lift vehicle, you're very dependent. There are other technologies that deliver the same goal, and I can show those technologies in the future form.
Where you mean in short takeoff?
Short takeoff, vertical takeoff. All of these technologies flow from good physics in aerodynamics.
Well, that's absolutely fascinating. I mean, talking about good physics, good engineering, we've always been taught that good engineering is beautiful. Boy, this is beautiful. This is good engineering. Thank you very much.
Can we get close to the mural? This is 4,000 photos of my family and I building this aircraft in our family garage.
Wonderful.